Hi, my name is Monique Jones. I am a technical product manager of Intel DevCloud for the Edge. Today, I'm going to show you what DevCloud is and how it can be useful to you by showcasing a demo. So Intel DevCloud for the Edge is a free platform that allows you to actively prototype and experiment with AI workloads for computer vision on Intel hardware. To start, let's get familiar with the website. So here, you would navigate to devcloud.intel.com/edge to get to the website itself. Pay attention to the announcements. We put, when we upgrade OpenVINO, any of our latest features or new samples that come on board is all showcased here. We also have, overviews for OpenVINO if you want to get more familiar with it. If you want to understand DevCloud better, you can click the DevCloud overview. And then we also have tutorials, samples, and other solutions that you can actually, look at on the DevCloud. Here you can click this link for tutorials, or you can come here and underneath advanced and, go to the respective pages such as sample applications or some of the advanced tutorials or the edge solutions that are for, industrial use cases, or even deep learning workbench. And then if you just wanted, use the DevCloud as is, you can just connect and create to, one of our development servers. We also have a lot of hardware that we host on DevCloud for the Edge. So, if you're interested in the hardware that we have available, you can click any of these device links for further information. So the DevCloud overview page is where we like to tell people to get started. And so this is how it works. You as a user, you connect to the development server. We have Jupyter Notebooks and Jupyter Labs hosted here. We also have Git hosted so that we can sync our repository that has awesome samples and tutorials. We also have a storage server and that stores all the videos, images, all the data sets, anything that your application would need to run. And then what you do is, you would submit your application as a job to the job queue. And then based on the device that you're targeting, it will, it will send that job to the specific device to execute on. And then once the job is finished executing, you'll get your results back to the development server. So I'll showcase that flow with the ONNX object detection sample here. So the ONNX object detection sample is a sample that uses TinyYOLO v2 for object detection to detect, in a clean room use case, people with bunny suits, glasses, heads, the robots in the fab, or if the person is unprotected in the fab. We do this, using ONNX runtime, using OpenVINO as an execution provider. So all the inference is done using OpenVINO. And just for this demo purpose, I've ran all this ahead of time. So here you can see, this is kind of an overview of what I just stated, and we use OpenCV for pre-processing and post-processing. So that's some of the objectives you'll see here. And then of course, inference is, being performed on the edge hardware using OpenVINO. So first we install ONNX runtime for OpenVINO, which I've already done. We import some dependencies that are needed for the notebook to run. And then what we're going to do first task is we're going to run inference on a single frame. So here are some of the functions that are used, some of the post-processing function to render the results, pre-processing to make sure that the frame's shape is the same as the input layer of the model shape, and then the run inference function that gets the model path, the device, the input video, and then we set some of the options and do some of the configurations up front, and then we open the video and we loop through the video frame by frame, but we stop after one frame. So this is just one image that we're going to be doing inference on. So here you can see that the results of that inference, you can see people are detected, the bunny suits. So this is all done on the development server that I spoke about previously. And so you're only allocated 1 core and 6 GB of RAM. So if you want to do anything more computationally exhaustive in your application and you want more resources like a whole device allocated to your program, you should submit a job to an edge node. So that's what we'll go over next, is by looking at the whole input video that is going to be our test video. for inference that we'll be submitting to the edge node. So this is the video itself. So like I said, you need to create a job file, and a job file is nothing other than a bash script. And here you can see the bash script takes the -m, the path to the model, -i, the location of the input video, -o, the directory to store the results, and -d, which is the device type. And basically this job bash script just basically takes those values for those parameters and passes those to the actual application itself here. And then if you're running FPGA, we set up the FPGA environment accordingly. Then we have PBS nodes command that tells you all the different tags we have for all the devices on the DevCloud. And so next, we're going to set the environment variable video to the path of the video, and we'll use that in our job submission command. So we use qsub as the job submission command. We give it that bash script. We give it the node to actually execute on, and then we give the -f flag with these parameters that are going to be sent to this bash script. So the -d with the value -m, -i, and then -o. And then this -n is the name of the actual job itself. So for demonstration purposes, I'll just rerun this one job. So here you can see that we're not only sending it to this Intel Core i5 6500 TE system, we're also going to be sending it to the Xeon, to GPU, to FPGA, and to an up-squared development kit that has a GPU on it. And so these devices have already ran previously to this demo. The one that I just ran, you could see this is the job ID, this is the name, the user, and what's really important is the status. So you can see that it's running. You can pay attention to the QStat here, or you can look at the progress bar as it's progressing. So I'll just go ahead and go down and I'll showcase the results for the different devices. So here you can see some wafers are being, now wafers are being put in and out the robot arm in the tool. You can see it's detecting the head, the glasses. In this video, you can see it's detecting robots, bunny suits. And so we've got our results back. And then we also have performance comparison charts so that you can get a side-by-side view of how your application ran. And the metrics that we have and demonstrate here is inference processing time and inference frames per second. And so here you can see that the FPGA has been the clear winner here. And so this is the demo here. Thank you for your time. We hope that you enjoy DevCloud for the edge and create something great. Thanks.